Welcome to Unit 6 on energy conservation. We're going to begin by looking at policies and practice. Why do we need to conserve? It's effective. So in the 1960s, energy consumption exploded. And then the cost went up in the 1970s, which prompted conservation. At this point, things like President Carter's highway speed limits were put in place. Remember, that restricted the speed limit on interstates to 55 miles per hour. Conservation efforts held energy use constant from the 1980s through the 2000s, all the while the gross domestic product was growing. So what causes high energy costs? It's all about supply and demand. Back in the 1970s, there was an oil embargo from OPEC. Because we were dependent on the oil from OPEC nations, they were able to impact our energy supply. And the U.S. had indicated that we would have troops in the Middle East with an inevitable war if we continued down the existing energy policies that we had in place. In response, things like the corporate average fuel economy regulations, or CAFE fuel regulations, were put in place. They were enacted by Congress in 1975, and they were intended to improve the average fuel economy of cars and light trucks sold in the United States. You can calculate the regulation for a vehicle by taking the sales weighted harmonic mean fuel economy, expressed in miles per gallon, of a manufacturer's fleet for the current model year of cars and light trucks. So if you look at Chevy, it's everything Chevy produces that is a car and a truck. As long as it falls under has less than a gross vehicle weight rating of 8,500 pounds or less. Here is the result of the regulations. So let's begin by looking that the vertical axis is fuel economy in miles per gallon, and the horizontal axis is the year. The open orange triangles is the CAFE standard. The closed triangles are for light domestic trucks achieved. I should say that the open triangles are also for light domestic trucks. Notice that the achieved is just about everywhere larger than the CAFE standard, which is good. That means we're exceeding what the standard was. Similarly, for cars, the standard is in the open blue squares up near the top, and cars have out-achieved the standard, just like trucks have. If you take the total fleet and look at it, it's the black line, which is midway roughly between cars and trucks. Let's look at actual versus projected fuel economy of passenger vehicles by country and region for 2002 to 2022. The vertical axis is miles per gallon. The horizontal axis is time. Notice that in Europe and Japan, the usage, both actual and projected, is very high compared to everywhere else plotted. Also notice the United States is one of the lowest. California out-exceeds most of the rest of the United States. It has different standards. California is much more stringent. Other things we can do to conserve. We can change our light bulbs. Instead of using the standard incandescents, which are very energy inefficient because they lose a lot of energy to heat, we can use compact fluorescent bulbs. They cost more than an incandescent bulb, but they emit 4 times as much light for the wattage and last 10 times as long. Thus, it saves about $50 in energy use over the lifetime of the bulb. You could also go to LEDs, light-emitting diodes. They're even more efficient with 90% more than incandescent bulbs. They last hundreds of times longer than incandescent. You can easily adjust their lightness and color, and they can be used for just about anything. Christmas trees, street light, flashlights, they're even on automobiles these days. This graphic is showing that one compact fluorescent is equal to roughly 9 incandescents. These are LED light bulb, Christmas bulbs down here in the corner. That's an incandescent, and these are different styles of compact fluorescents. This is a comparison chart. Here on the left we have one high intensity discharge light, and it is equivalent to 10 T5 fluorescents, 4.5 self-ballasted high wattage fluorescents, 42 T12 fluorescents. I don't know what the difference between a T5 and a T12 is, dreadfully sorry, or 85 60-watt incandescent standard household bulbs. Again, you have to pay more up front, but again, another comparison of energy efficiency. The left-hand column is the wattage of incandescent light bulbs. The middle column is the amount of light output, and the right-hand column is the Energy Star qualified light bulb wattage. So a 40-watt incandescent light bulb is equivalent to a 9 to 13-watt Energy Star light bulb. And remember, this is because incandescent light bulbs lose energy to heat. Other things you can do. You can improve the energy efficiency of your home. Today's home use 50% of the energy required for houses built in 1974. So what's different? We've caulked. We've used higher efficiency heating and cooling systems. We've increased insulation. Basically, anywhere there was a draft, we've tried to get rid of the draft. Here is a schematic of a house showing where the drafts might be and how we might, for example, in winter bring cold air in and lose warm air. So cold air can come in around electrical outlets, around dryer vents, around doors, around windows, through chimneys, into crawl spaces, in the kitchen fan. You can lose hot air to the attic through recessed lighting, through gaps around the chimney again, through the hatch, vents. So caulk, insulate, make changes. Here are ways you can increase the energy efficiency of your home. Make sure that your skylight covers are caulked, they're sealed. Use a good insulation. Check your soffit vents. Put in thermally good windows. Use solar screens. 5 is actually caulk. I can't say it enough. You can also design your house such that it makes the best use of solar energy. Here is a south-facing home. The windows very much let natural light in, so you don't have to lose lose energy by running a light during the day. But it also has eaves and solar shades to keep the house from getting too hot, so you don't have to run your air conditioning as much. Other things you can do. Flip a switch. If you're not using it, turn it off. Standby mode for TVs, DVD players, printers, cable boxes continually draw power and can represent 25% of your monthly home electric bill. If you put your computer on sleep mode, you're saving 90% of the energy. Use a motion activated switch. There is a question. History has shown that if we raise the cost, the usage goes down. So should we consider raising the cost in order to reduce usage? Other things to consider. What should the energy of the future be? Here are some criteria that you might want to consider. Should it be sustainable? Should it be renewable and environmentally low impact? Should we stress conservation, minimizing usage? It has to be economically viable. If it's not, people won't go for it. It has to be socially equitable. All people at all income rates have to be able to access it. And it has to be globally available. It doesn't help to institute a new type of energy in the United States only to have a different country like a current India not have access to it, because then you're just moving the emissions elsewhere.